A reflection uses a line as a mirror, so every original point and its image sit the same distance from that mirror line on opposite sides. We will first reflect a single point across line AB, then use the same rule on each vertex of a polygon, connect the new vertices, and compare the order of the vertices before and after the reflection. The key starting move is to turn the mirror idea into a precise construction for one point. Starting from the plan, line AB is the fixed mirror that does not move during the reflection. A point and its reflected image must lie on a line perpendicular to line AB, with line AB exactly halfway between them. With the mirror line fixed, draw the perpendicular path from point P to line AB and mark the same distance on the opposite side of the line. The new point on that path is the reflected image of point P. Now that one point can be reflected, the same perpendicular and equal distance rule applies to each vertex of the polygon. Each original vertex gets a matching image point across line AB. With all the image vertices placed, connect them in the same vertex order used by the original polygon. The connected image points form the reflected polygon. With the reflected polygon assembled, follow the vertices around the original polygon and then around its image. A reflection reverses clockwise order into counterclockwise order or counterclockwise order into clockwise order, so the polygon's orientation flips.